Hello, everyone. My name is Mrinank. Yeah, and I'm really delighted to be here with some of my colleagues at Anthropic.
Hi, I'm Jerry. I'm on our safeguards research team, and I've been at Anthropic for about 8 months.
Hi, I'm Ethan. I've been at Anthropic for 2.5 years, and I'm leading our efforts on AI control, developing various different monitoring methods for various different AI risks, including adversarial robustness. And I was a part of the safeguards research team as well before.
Hi, I'm Meg. I've been at Anthropic for about a year and a half now and on the alignment science team, which has been great.
Great. So yeah, and we're just going to be talking about constitutional classifiers, and that's our new approach to really try to mitigate jailbreaks. So yeah, how would we define a jailbreak?
Yeah, I mean, I think to me, a jailbreak is kind of like some way in which someone can bypass the safeguards that we include in our models and try to get harmful information out of it.
Yeah, so there are these techniques like, the do anything now jailbreak. It's kind of similar to, people would jailbreak their iPhone and try to get around all the safeguards there. But the thing is that, with iPhones and, other stuff like this, jailbreaks aren't really a thing that people that maybe aren't that dangerous, not something that we care about that much. So yeah, what is it that makes, why should we care about these jailbreaks in the first place,
I mean, I think one of the main reasons is for future models, which have greater risks. So, I think people are pretty carefully monitoring, people at different companies and the academic community is pretty carefully monitoring, if/when models will be able to help with weapon development or, large-scale cybercrime or various different risks that are greater than what we've seen before, also mass persuasion, things like that. And I think, once models become really effective at some of those and are a significant uplift over, say, using Google search or general internet resources to do some of those things, I think I guess being able to use models to help with those kinds of things will be, potentially speed up bad actors quite a lot. So I think a lot of this is in preparation for next generation models or next generation models.
Yeah, great. And then I'm also curious what the story of the work is and sort of why we set out to do this in the first place and the RSP.
I guess Anthropic really cares about safety a great deal. And we have the RSP, which is the responsible scaling policy, which is really trying to outline conditions under which we're happy to release models and make sure we have different safeguards in place. And a while ago, we committed to a very difficult standard for jailbreaking the RSP for what we call ASL3 models, which are basically models which have maybe some of these dangerous capabilities, like being able to build dangerous weapons. And our team was kind of mandated with trying to actually solve jailbreaks for this kind of level of model. I guess the motivation for the work is actually try and satisfy the things in the RSP such that we can feel like we build future models safely and can actually deploy them with some sort of progression towards safety or making some progress towards that. So I think the classifiers are definitely a good step in that direction.
Yeah, so, there are lots of different types of jailbreaks that are out there. And something that we've really did in our work is we focused on universal jailbreaks. So yeah, why is this something that we should care about? What does that mean? Why is it important?
Yeah, I mean, I think the reason why I'm particularly concerned about universal jailbreaks is just because of the uplift that it would give kind of a non-expert. And the way I kind of think about this is that if some random person on the internet is trying to do something bad, they may not actually have that much jailbreaking experience themselves. And so the thing they might just do is just go online and see what are some existing jailbreaks that I can use? What's a template where I can just put in my harmful question and just get an answer. And I think in that case, you're very concerned about these kind of strategies where anyone could just put in any question and it gets the model to bypass all of the safeguards. And I think that's particularly concerning at the level of model capabilities that we're concerned about.
So how exactly would you define a universal jailbreak? If you're telling someone on the street, what does a universal jailbreak mean? How would you know if your jailbreak is universal?
Yeah, I guess like there's a little bit of ambiguity there, but I think the kind of like definition that we're going for is some kind of prompting strategy. It could be automated, but just a singular strategy that's like very easily replaceable with any like wide variety of harmful questions, and that consistently gets a lot of detail from the model and like bypasses the model safeguards.
And I think one way of quantifying the universal jailbreak is that it like actually does speed up a person quite a lot, because instead of having to jailbreak every specific query, they have to they can just use one jailbreak for all of the queries, which actually is a lot faster. So I guess like one idea is like if there's some counterfactual way of doing thing that's much easier than using the model, there's no point in using the model. So not having universal jailbreaks might mean that they try other strategies, which might be worse or something like this.
Yeah.
One thing I would maybe add is that like the difference between a universal jailbreak and non-universal ones is like for non-universal ones, you might need to, for every harmful question you want to answer, you would need to jailbreak the model in particular for that particular question. Then you get a new question, like a new, I don't know, your next question in the process of developing your new weapon or whatever. And then you need to jailbreak the model again. I think basically like that entire process, if you need to do that hundreds or thousands of times, is just like very costly. Whereas if you just need to like upfront find one strategy for jailbreaking your model, like a single prompt where you can just swap in a new question, that makes it so that it's like, the amount of total effort for jailbreaking is like much lower. So that to me is like one of the primary motivations for focusing on universal attacks.
Yeah, and I'll just give an example here and a way that I think about it. So let's say I want to make a cake, and I'm not able to make a cake because I've never baked in my life. I don't know anything about ingredients. I don't know how things work. So how could a model be able to help me do something I can't do otherwise? So if I need to make a cake, I'm going to need to ask a bunch of different queries. That's one thing. Like it's actually like I'll put maybe I'll put something in the oven. I need to know like if the temperature's right, the smell's right, take it out, how I would check, figure out all the ingredients. So one thing I think that's really important in the universal jailbreak sort of definition is that sort of you're very confident that the information you're getting out of the model is actually really helpful for the thing that you care about. So it's kind of different. There are sort of some techniques that get like a little bit of information, or they get some information but it's sort of mixed in with a lot of other stuff. But for these sort of scenarios where what's happening is an actor that can't do a task that requires a lot of expertise, we're worried about them being able to do the task. We think that they'll need to have access to this sort of universal jailbreak. They'll need to be able to ask many queries and get really reliable information, and they should just know, oh, this is the correct instruction, this is the right thing to do.
I think an example of a non-universal jailbreak that someone on the team, I think Jesse Mu, found was, I think he was jailbreaking it for asking Claude how to make meth, and he found some jailbreaks where he puts the model in a scenario where it's role playing as if it's part of Breaking Bad, the TV show where they make meth, and then asks the model the question, how do I make meth? That kind of jailbreak, you can imagine how that like would be effective for like that specific kind of question, like things related to meth, but is not going to generalize for things related to like cybercrime. But on the other hand, there are some other jailbreaks which like the do anything now jailbreak, which gets the model to do anything by getting it to talk in a certain mode or role play in general for arbitrary questions. And that would be what we would call a universal jailbreak. There's also other strategies people have used to make these, like using language models to automatically find different jailbreaks. That would be a more kind of like dynamic approach that might be able to discover these on the fly. But if you have a single process for generating a jailbreak for like a new question, that would also count as universal.
So yeah, and just maybe an even more basic question is like, why does someone need to jailbreak the model in the first place? You know, what does that even mean? You know?
Yeah, I mean, I think we've done a lot of work, such as our constitutional AI work, on getting Claude to have this kind of characteristics where it doesn't actually try to give harmful information if it thinks like the user might have some like bad intent or something like that. And so for a lot of these harmful questions, if you just ask the question itself, it's like very obvious that this is like bad question. Users trying to like make some weapons of mass destruction. It's like very clearly bad. And we've trained Claude to not answer those questions. And so the jailbreak is needed to actually get around those safeguards in order to get Claude to actually answer the question.
Another thing that's relevant for the like harmlessness training question is that I guess like there's many different ways in which people could present jailbreaks to the model. And there's also many different tasks that the model needs to be able to do in its kind of everyday life, so to speak. And I think having like an extra set of like systems that are like specifically trying to guard against jailbreaks can really help have like, I don't know, like some kind of like Swiss cheese sort of method of like trying to block like harmful things via like many different layers or something like this.
Could you say more about what this like? we talk about Swiss cheese a lot on Anthropic, but you know this is not as well known everywhere. So yeah, what does that mean?
Yeah, so I guess the idea of the Swiss cheese model for like protecting against things is that maybe if you have like only one system for preventing harmful things from happening, there may be like some specific problem with the system that people can exploit and get through every time. But then if you add kind of like a layer of Swiss cheese which has like a hole in a very specific place, maybe like the rest of the cheese blocks all of the harmful attempts, but there's like a specific hole. But if you add another layer of Swiss cheese, the hole might not be in the same position. So if you have like 2 layers of Swiss cheese, it's actually much harder to get through things, even though they both may have holes.
Yeah, so what are these layers of cheese for like our method? We've been talking about constitutional classifiers. So yeah, what are the different sort of layers of defense that we're going for here?
Yeah, I mean, the first layer would kind of be our input classifier. And the input classifier here is looking at basically the entire conversation that the user passes into the model. And so that's the first layer. And then the second layer is if it gets past that input classifier, Claude itself, which is the model that we're trying to guard, can actually refuse to answer the question. And then that's kind of like another layer of like Claude saying, okay, maybe this question's not so good. Maybe I shouldn't answer it. And then finally, we have this output classifier, which kind of like looks at what Claude is outputting in real time. And then if it ever sees something that seems like it's like dangerous or seems like it's against some value that we're trying to block, then in that case, it can also choose to stop Claude's output and block the response.
And how do these classifiers, what are they looking for? And, you know, how are we specifying what to look for?
So I guess like in our paper, we call them constitutional classifiers because we have this kind of like natural language set of rules. And this is like some like set of rules where we can specify some categories of topics which are like not okay to talk about. I guess like an example could be like, you know, creating weapons of mass destruction, clearly bad. And we can specify, let's not have Claude tell the user how to make that. And then we can also specify some examples of harmless stuff that Claude should be allowed to talk about. And then basically we train our classifiers to classify whether conversations or outputs are related to these kind of like harmful or harmless categories. And then that allows us to make a decision on whether to block it.
And crucially, like, I guess the input classifier and output classifier are kind of like doing 2 different jobs. Going back to the Swiss cheese analogy, we hope that the holes of the Swiss cheese are in different places, specifically for the input and output classifiers. So I guess the input classifier is kind of like doing the really naive thing that you'd expect. Like it really looks at the user prompt and tries to work out whether there's anything harmful going on. But crucially, one of the reasons that you might need an output classifier as well as the input classifier is that people are trying really hard to jailbreak the model and the input classifier in the prompt. And if you have a totally separate output classifier, which is only looking at the output, that only ends up looking at stuff that the model itself has produced. So it's kind of somewhat decorrelated from what the user put in. So like 2 parts of the system are looking at things directly that the user put in, but we also have this like kind of third held out part of the system that the user actually doesn't get to touch directly, which makes it a lot harder to kind of like completely jailbreak the system. And although the input classifier and Claude are doing a lot of the work, the output classifier is doing, is doing some important thing as kind of like the last crucial component for like really driving down, harmfulness rates.
So this is true and it makes a lot of sense, but most people aren't using Claude for this. You know, most of the time that people ask queries, they're just doing something completely great, like something benign, legitimate, like a really beneficial application. You know, so we could have guards that just block everything that would be completely useless. So yeah, how are we making sure that sort of we're not overzealous there?
I mean, I think we really want to, part of why I think we're designing these techniques is to allow as much useful content to be and useful work to be done by the models. Like the better techniques we have for blocking exactly, precisely just the really harmful content, the better we can not have false positives for users who are using models for really good applications. I think I think the classifier approach like makes some progress there and might be better than other approaches, like directly training the model to refuse. And so I mean, I think hopefully this leads us to allow users to talk with Claude about lots of CBR and related topics that are safe to talk about. And so I think our hope definitely my hope is to allow for a lot of those applications to like thrive while just narrowly blocking out the things that we believe are dangerous.
Yeah. I guess crucially also, I think we often like make the joke that if we had like just a rock as a model, that would be extremely harmless and that it would not in fact answer any harmful queries, but unfortunately would be not very useful. So I think, making sure that we don't block harmless queries is actually a thing that is actually quite important and also actually quite difficult.
Yeah, and Meg, you mentioned before kind of like solving jailbreaks or like making progress on this problem of robustness. Like, how would you even define that, or what does that actually mean? You know? Yeah,
I guess this is a very difficult question. I guess it involves like a bunch of different layers. Like, firstly, there's some idea of like threat modeling. Like, you have to have some idea of like what it means for something to be harmful. The Frontier Red team has done like some amount of work in trying to like specify what things we're actually worried about. This is somewhat hard because, as Ethan was talking about earlier, we're talking about a lot about future models and potential future model capabilities, which we might be really worried about. So I think part of it is like mapping out what might be harmful, what we might need to like address. So threat modeling, like what is actually harmful. Then there's like the job of like actually measuring harmful things. So that's a lot about I guess like we're using our like constitution to like kind of like define the threat model and then having like models generate various synthetic data to try and kind of like enumerate various harmful things that could happen. So measuring like a true positive rate on the data. But then there's also trying to make sure that we don't refuse too much on like real data from Claude.ai and make sure that we actually can, be as helpful as possible while still being safe.
So what actually is the Constitution? You know, these are constitutional classifiers. We're talking about a constitution. Like, what does that mean?
Yeah, I mean, the Constitution here just kind of means like some enumeration of categories of requests and conversations that we kind of deem harmful versus not harmful. And so examples here could just be like, questions on how to make weapons of mass destruction, or like trying to source ingredients for making weapons of mass destruction. And then we basically just enumerate some of these categories. And then we also specify some categories of like harmless stuff, like, I don't know, like writing poems or like writing code for like normal use cases. And then we can just kind of like specify these. And then we, as Meg said, we generate a bunch of synthetic data that gives more specific cases of those.
What do you mean by synthetic data?
Yeah, so here in synthetic data, we kind of mean that we start from these like broad categories of user requests. And then we have Claude actually kind of like branch out and like think about all the specific requests that might be examples of this kind of like broader category. And so, the category might be something like sourcing materials to build weapons of mass destruction. And then sub requests there might be like, what specific stores might I go to? Or like, are these specific materials accessible at, I don't know, in X state? And so we have this process for automatically doing this. And that allows us to kind of like generate a huge amount of synthetic data from just a small amount of categories.
Yeah, and I think something that I find really cool about the method is that it is just based on like natural language. You know, we were talking about threat modeling before, and threat modeling, at least in my experience working with Frontier Red Team, is that threat modeling is really hard. You know, there's a lot of people using Claude. It's really hard to like, what are all the possible things that could happen? And we're gonna learn new things, you know, as we have monitoring, and as you know, we always learn new threats or new things that could happen. And yeah, something that I find really exciting about the method is that basically, if you want to change the Constitution, if you want to change what is being blocked, because you've learned something new, you know, maybe this thing has come out on the news, or there's some like intelligence or like monitoring the only thing that you actually need to do is you just rewrite the Constitution. And the standard approach for sort of classifiers is you would like ask humans to get a lot of data. So, something could happen is that, we're really focusing on, one category, like one particular way of maybe like cyber misuse. But we later realize that, actually, there's something which is much more dangerous, or something that we've just learned something new, or someone's informed us. Something that I'm really excited about is that this is a way that I think we can get good robustness, but we can like maintain our like flexibility and really maintain our ability to like respond to like novel threats and adapt to what's actually happening. Because I feel like this is just the lesson that we learn like again and again. If you don't have flexibility, it's sort of going to be a problem, and it's going to sort of limit us.
I actually do want to make a quick point on the flexibility thing, which is that I think like our approach is not just like flexible and kind of like switching like general topics. For example, if you wanted to go between like cyber and like, I don't know, like weapons of mass destruction or something. But I think it's also like a lot more fine-grained than that, in that during this project, we saw that like there are some requests that our early classifiers were like always very suspicious of, but they're actually benign. And what we could do is we could actually just like modify the Constitution, add like one sentence that says, these types of requests are okay. And then when we retrain the classifiers on that new data, the classifiers would no longer flag those benign prompts. And so I think that allows you a lot of like fine-grained control over what exactly your classifiers are trying to flag, especially if you see a lot of like over-refusals or problems with like missing stuff.
Yeah, I mean, this might also be a good place to give a shout out to, we had a paper earlier on rapid response where we kind of leveraged like a similar idea to improve the safeguards around models. And I think basically, one nice feature about using synthetic data is like if you notice not even just a new category of jailbreak, but just a new kind of jailbreak that maybe applies. Like, let's say we notice a new universal jailbreak, like the do anything now prompt. We can take that, use an LLM to generate variants of that, and then throw that into the data mix. And like, I think, my understanding is this like was really helpful for us in like developing the classifiers to the level of robustness that we got. If someone reports a new like jailbreak or vulnerability, then like we can use that to like really quickly update the classifiers by using some synthetic data generation pipeline. And that really will like minimize the like fraction of time at which there's like an outstanding like jailbreak, which can, just make it so that the models are like vulnerable for like as small a period of time as possible.
Yeah, it's the common wisdom, I suppose, that like not like perfectly solving security is basically impossible. There is no like perfectly secure system like known to humanity. So I guess we need the flexibility both, for this like, we're blocking the wrong thing, or we're blocking benign users. But when people do find things that get through the system, we want to be able to fix those really quickly.
Yeah, I think part of our approach here is that we've kind of like modeled jailbreaks in a way that like it's very easy for us to add examples of new jailbreaks into our kind of like training pipeline. And so if new jailbreaks are discovered, it's quite easy for us to just generate more examples of those jailbreaks and then train on them. And then hopefully those classifiers will be more robust too.
Yeah, I think one other thing I would add that's nice about classifiers is that they're decoupled from the actual text generation model. And so I think often it can be very difficult to update the text generation model, that if you train it to refuse in one domain, maybe that generalizes in non-obvious ways to behavior in other domains or refusal behavior in general. I think we definitely ran into some difficulties doing like preliminary work on that. But I think with the classifiers, you can just like keep the text generation the same and it's identical to previously deployed model. I think that gives customers like a lot of assurance that there are no like major changes happening in general to the model, the kinds of text outputs you're getting, and the only change that's being made is just the block or no block decision, which you can iterate on separately from the model. So I think that that also makes the rapid redeployment like way easier than we would otherwise be able to do.
So how did we come up with this approach?
That's a great question. I feel like we spent a lot of time thinking about it. I think classifiers like stood out, I think for the reasons that we've just been talking about. They're like extremely flexible, can be like easily updated, like to respond to like various novel threats. yeah, I think threat modeling is really hard. So having a thing that's like super flexible is great. It's lightweight. It doesn't increase inference cost as much as, I don't know, I guess like we can kind of like distill down something that's like somewhat more complicated, like constitutional set of rules into like a somewhat small thing. And yeah, I think that all these things make classifiers kind of like a nice way of like iterating really fast on the kinds of things that you're hoping to achieve. And then I guess we tried it and it seemed like it was working, so we kept going.
Yeah, I think this was really due to the responsible scaling policy that Anthropic had. And yeah, I mean, I think we would have done other safety research if not for the responsible scaling policy.
Wait, what is the responsible
scaling? So yeah,
scaling
the responsible
policy?
scaling policy is basically Anthropic's plan for how to ensure that our deployments are safe. And yeah, basically it outlines different like red lines for capability thresholds at which there's basically a new risk that kind of comes online with like more capable models. Let's say models are capable of developing a very dangerous chemical weapon, then the associated mitigation in the RSP is get above some sufficient level of robustness to jailbreaks so that the model is not actually in practice with the mitigation sufficiently helpful to an adversary who wants to do that. So yeah, I think in the original RSP, there was basically this commitment to once models get to a sufficient level of capability at assisting with potentially proliferating knowledge about known weapons of mass destruction, that we would then have the ability to, it was the wording was vague, but basically successfully pass red teaming. Like the RSP was already written, the company committed to this publicly, and Jared Kaplan, who's like head of research at Anthropic, came to us, and like other people came to us and like raised this line to us, and we're like, hey, you guys should try to solve adversarial robustness.
We memorized the line first.
We memorized the line, we printed it out, we framed it and put it on our on the desk that we were working in. But yeah, and then I think that was really thinking about that line in the RSP basically like made us really reflect on our life choices about what research we were doing, both in terms of like, should we work on robustness or not? In the sense of like, it really made it clear, like, okay, there's like significant harm that could come online like in the next generation or two of models if we don't solve this problem. So the urgency is like higher than other problems we might want to solve. And then also in terms of what specific approaches we would take. I think, you know, initially when we were like, oh, we should maybe do some robustness research, I think the general mode that like I had been in research and like a lot of other researchers in general is just like, okay, let's just like take some interesting, like useful research problems to solve here, explore some questions, write some papers. And I think that's the thing that like a lot of the people on the team know how to do well. And we sort of explored a bunch of like maybe more salient approaches.
I think there are like so many things that are interesting here for me. One thing was like right when this started, I had like just finished my PhD, or it's kind of like around the time I was finishing my PhD. And this like classifiers thing, there's this Anthropic slogan, and like the Anthropic slogan is like, do the dumb thing that works. And I kind of think this type of research, it's often the type of thing that maybe isn't that shiny or that like kind of like, you know, interesting for researchers. And I remember, yeah, I think without the RSP being like, okay, like really pragmatically, if we care about these risks and we think they're real, like what is the way to get there? And kind of setting aside this like, oh, what's kind of like more interesting or, you know, shiny, is like, what is the way we can actually like make this safe? In some sense, like our job is, you know, we're genuinely thinking like, wow, like, you know, this isn't happening now, like these are future systems. So I'm just like, what has that been like, you know, for each of you, and sort of individually kind of like working at Anthropic and sort of like being there like in the midst of all this.
Yeah, I think they take the safety risks of future models like very seriously. I think there's very real risks. There's obviously these like misuse risks that you've been mentioning with like CBRN risks, which are like chemical, radiological, biological, nuclear risks. But there's also like very real like misalignment risks. And I think it's really hard to deal with. I think one of the things that I find good is that I do think we are like as a team like very committed to like actually trying to really solve the problems. And I think doing the classifiers project was like some evidence in favor of like we really, really care about actually solving these problems, and we actually want to find like an empirical solution to doing the things rather than like as kind of you're alluding to, like just doing like research that like looks good but doesn't actually like accomplish a thing in practice. Like I think we spent a lot of time doing very like I don't know not like I don't know I wasn't really aiming to get like a paper out of it, but I think we like actually managed to like accomplish something that was like slightly more real, which I think is good. And I feel like this is just this feels like one step forward, but there's like a long way to go for me.
I mean, I guess I'm slightly more optimistic. I think the risks are definitely real, but I feel like we're making decent progress. And I think like probably if we like keep working on the problems like just pragmatically, we can make a lot of progress and just reduce the risks dramatically. I don't think we'd ever like reduce the risk of like AI to like zero. But I kind of like see AI as a tool, and if we adopt the right safeguards and we do the research that matters, I think we can make a lot of progress here, and that's like ultimately the best that we can do.
Yeah, I think sentiment wise, I'm like pretty similar to Meg in terms of being like, I think there are like very serious risks here. I'm definitely like pretty concerned about a lot of the risks, and like I guess I'm like, well, the best I can do is like help reduce the risk by like some amount. I think like I do think that this project like made some progress on that, and I'm like pretty excited about that.
I mean, at times it's like overwhelming. It's like what is it to like really like internalize what might happen, and then there's like a desire in me to like just like show up here and do work in like a trustworthy way, and that there are challenges, but we can make progress there. And I feel like we've made a bunch of progress and really excited to sort of share the progress with others. And, we could have not written a paper, but we did decide to write a paper and sort of try to sort of get it out there and sort of share the approach. Yeah. And, sometimes it's overwhelming, and other times it's more the sense of like real like privilege and like honor of like, wow, it feels like I'm really doing like meaningful, important work. And also not to forget all the beautiful things that could happen with like really beneficial AI. Great. So, something we've mentioned here is that like we think we've like made progress in terms of robustness. Like how have we tested this? How do we know? What do we think that progress means?
I guess the overall summary kind of on whether we're making progress is kind of like, how hard is it to find a universal jailbreak for a system without like increasing over refusals too much, or like increasing the compute costs of whatever system you're trying to deploy. And so like there's different ways you can measure each of those aspects. So in our paper, like one way we're looking at how hard is it to find universal jailbreak is we actually just like had human red teamers try to find jailbreaks for our system. And then we just kind of like tracked how many hours did it take for them to find a universal jailbreak, and did they find one?
Yeah. So could you actually like walk me through kind of like where we were before the project sort of started?
Yeah, I mean, I guess we started with, first of all, if you just have the model itself, like it has some like basic training to try to like refuse harmful queries. But of course, there are a lot of jailbreaks that exist that work on our models. And so those jailbreaks are also just like kind of available on the internet. And so in theory, anyone could jailbreak the models. And that's kind of like our starting point.
How hard would it actually be? Like if I want to, jailbreak a model, like what would I actually need to do right now?
I mean, you could go on Twitter and find existing jailbreaks.
Yeah.
And basically in like a few minutes just jailbreak an existing model. Like I think they're just examples on Twitter where like while a model is being demoed live for the first time and it's just generally been made API available, like someone jailbreaks it and immediately posts it. Like that was the level of robustness like before this with a universal jailbreak. That was like the level of robustness like when we started this project. And now just to like give the punchline, like we with these systems with the constitutional classifiers, we're able to get thousands of hours of robustness to red teaming, where we do very large scale red teaming with like yeah, people who were testing our red teaming our systems, like including like expert red teamers, and yeah, recently put out for like public red teaming, and yeah, it took like I think over like 3,000 hours worth of like red teaming effort for people to find a universal jailbreak. So I think in terms of like, yeah, going from sort of like minutes to like thousands of hours, it's like several orders of magnitude more robustness. There are still some universal jailbreaks, and like we have, we need to like patch the classifiers and stuff like that. But I think, I think it is like a huge amount of progress.
Yeah, so I like to think like we had a system which, you can just basically pretty easily jailbreak it. You read a paper, you go on Twitter, and then we red teamed the system back in September, and it wasn't a complete rock, but it was like, you ask a question to Claude and like half the time it gets given to a rock and you get no response. So it was like, it was pretty robust, but it wasn't doing that well for, sort of most normal users, right? But that also got this, like thousands of hours to universal jailbreaks. And then so with the demo system that we just put out, yeah, that is doing way better in terms of like normal user usage and inference costs and sort of getting like good robustness. There's a lot of progress there and a lot more work to be done. Yeah.
Yeah, I think the comparison between kind of like our prototype September system versus the system we just demoed is actually like the difference is pretty like night and day. So like we did a lot of analysis here.
Jerry has the most beautiful graph of the false positive rate just dropping and dropping and dropping over time.
Yeah.
It's really one of the best things I've ever seen.
Yeah, so we measured our like over refusal rates on Claude.ai traffic. This is like real user production traffic. And we're kind of like operating under the assumption that most people aren't asking about like catastrophic weapons of mass destruction related stuff. And so like originally we were finding that this like September system was blocking like 40+% of these like benign requests, which is like pretty terrible. I mean, you're approaching the rock there. But yeah, in our demo system, we got that all the way down to 0.38%. And of course, we still want to get this down further, but between like 40% and 0.38%, this is like 2 orders of magnitude.
So how did you actually make all those improvements? Like it's like, there's, and this is something you see in like a lot of also like the earlier safety work, kind of this like tension between like harmfulness and helpfulness. I would say for me, it's like kind of surprising that we were actually able to make as much progress as we did. So yeah, how did we get there?
Yeah, I mean, I think the two main improvements we made were first, we like really honed in on the Constitution idea, and we made it really like clear how to like delineate things that were harmless. And we found that adding this kind of like harmless set of categories of like things that the classifier should allow actually reduced FPR by a lot. And we have like some results in our paper for that. And I think that was like one of the most significant changes. Other changes include actually like solidifying the kind of like jailbreak styles that we trained on. And so that kind of allows the model to generalize better on like what exactly is a jailbreak versus just like thinking like anything is a jailbreak. And that also probably helped a little bit. But I think both of these things were pretty useful here.
Yeah, there's this really like nice plot in the paper, which is just number of data points and like performance on the evals and like how robust it is, and like kind of in the style of like doing the dumb thing that works. Like that is just like a straight line going upwards.
Yeah, I mean, to be clear, I think the system that we released for the demo still has a lot of false positives, but I think we're pretty optimistic about like further reducing the false positive rate for some kind of like to make something like more production ready. But yeah, I think that's kind of where we're at.
Yeah, so why did we do the demo? Like what was the demo? What was the point of the demo?
I think the main questions we wanted to answer from the demo were like, was our system as robust as we thought it was? And I think like one thing here is that from the prototype, we did human red teaming there, and we knew it was like quite robust. But then after that, we developed kind of like our own automated evaluations. And we weren't sure whether that generalized to like actual human red teaming. And so one question that we want to answer there is, does it actually generalize? And if some classifier does well on these automated evaluations, is it actually robust in practice? Mm-hmm. And so if we could get that answered, that's like a main thing. And I think another thing here is just like having people try it with the system and, seeing if it's actually like over refusing too much, And I think people were finding that sometimes it overviews on specific domain questions. Of course, this is like still a lot less overviewsy than our original system, which would just like refuse on like completely unrelated things. But I think that also helps us kind of like get to know what the weaknesses still are, and that helps us know what to improve in the future.
So how exactly do we set this up?
Yeah, I mean, I guess we've set it up on our we had this public facing demo, and then we tweeted about it to have people try to like red team it. We set it up such that there were like these like 8 sets of like questions that we didn't want people to be able to get the answer to.
Or just like 8 specific questions?
8 specific questions. And the goal was to try to like get people to find jailbreaks to get harmful, detailed information on each of these questions. And then ideally they could do this with kind of like a single universal jailbreak. Yeah, so when we're talking about universal jailbreaks, we care a lot about making sure that the responses are detailed and not just like some very vague information that we personally don't think is like, that doesn't give that much uplift to someone if they were actually trying to do the action that the question was trying to get at. And so the way we kind of evaluated this is we have these helpful only models, which are kind of trained to not refuse anything. And these kind of like would be similar to what a model would be if you had a universal jailbreak, as in they don't have safeguards and they will just give very detailed answers to questions. And so for each of these like 8 questions, we have a response from this helpful only model. And that's kind of simulating what would the response kind of be if you had a universal jailbreak. And then because there's some randomness in model responses, we kind of have this grader that compares a target response with that response from the helpful only model. And then it kind of like looks for whether there's enough detail that's shared between those two. And if there is, then we'd consider that to be detailed enough.
Nice. And I think we looked for like at least 75% overlap in the information or something like that. Or yeah.
I think the thresholds change per question. So I think in some of the first levels, which is like the less harmful questions, we had like slightly lower levels of overlap required. And then towards the later questions, we kind of increased that threshold to maybe like 60, 70%. And yeah, it's dynamic through the challenge.
Yeah, I find this like question of grading just like really, really like interesting in general, and also like kind of just challenging to do well. I think we made a really good effort, I think, on the demo system, but like it definitely wasn't perfect. So the way the system works right now is it's looking for sort of overlapping bits of detail between 2 answers. But we had this thing in our sort of external red teaming that we did where people would just sort of merge like 5, 6, 7, 8, 9, 10 different model responses that cover like loads and loads of detail just because they're so long. And by this metric of whether it includes details or doesn't include details, it would be considered harmful. Even though like if someone's giving me instructions to make a cake, and instead of having like, this really nice like step-by-step a bullet point list, you first do this, it's kind of completely scattered and random, and and the like everything is out of order. It's actually a lot less helpful than the helpful only model. The helpful only model sort of by design like has no safeguards. It's designed to give you the information in a way that's going to be maximally helpful to you. So I think this question of like what is harmful, what isn't harmful, what is an appropriate threshold is like quite a subtle and just generally quite a difficult one. And I think there was the sort of reaction to the grading system in demo was quite interesting. I think a lot of people found responses that sort of looked harmful. They had some amount of information, and then our grader would say there's not enough detail. There needs to be more detail, and this would be, I think, frustrating for people because they were like, well, what's the detail that's missing? I don't know what the information is, and in a way, I think that's partially by design. Like if I'm making a cake and there's an essential bit missing in the ingredient list, or an essential thing missing like in the instructions, I actually have like no idea what that is because of the threat model, because I'm not an expert in this. Another thing that I think is interesting, why is the helpful only response? Why is that the baseline response? Why is that the thing that we're actually comparing against? And I think something here is that we have a team at Anthropic called Frontier Red Team. And Frontier Red Team's job is to basically take advanced models and see what could happen with these models, do the threat modeling work that we were mentioning before. And what they do is they evaluate this helpful only model, and they say, oh, this helpful only model, we think this is potentially dangerous. Like it could be used to carry out some complicated process. So like if Frontier Red Team are like measuring like, oh, what is the risk of like a helpful only model? You know, and if the risk of a helpful only model or a model without safeguards is too high, we're trying to measure, or the way I think about it is like we're trying to measure like what's the gap between the model with safeguards and the helpful only model. So doing this like relative comparison, while it's like imperfect and certainly like bits of information that is harmful can get through, it allows us to sort of like do this estimation and do this comparison. But yeah, it's I just found the reaction to this really, really interesting on the demo. I think, yeah, it's quite a subtle point. And I think also, yeah, I'm excited for us to sort of develop like better grading techniques and better things that actually like measure like, okay, like genuinely, like how helpful like is this completion for the task that we care about.
Yeah, the other thing I would want to just say quickly is that it's also just like very unrealistic to get this kind of feedback on how detailed and correct the information you're getting is. Like that's actually a huge advantage as a red teamer. And I think that actually the fact that we gave that feedback, I think gives you a very clear feedback loop that you normally wouldn't have. But yeah, I think maybe we should just like talk about the results.
So someone did find a way to pass all 8 levels, but before that, our system was holding out for at least 5 days. And we kind of did this filtration of like, we tried to find what kind of users we'd consider like active red teamers. And for that, we were just kind of like doing this very conservative estimate as someone who at least passed one question. We're kind of saying, if you can pass one question, we're considering you to be like an experienced red teamer and you're like trying to break the system.
I think that's pretty concept. Like I'm not the best red teamer out there, but I'm going to struggle with the first question.
Yeah.
So yeah.
But yeah, by this conservative criteria, we had like 308 users, and these users had over 300,000 chats. And we estimated that they had over 3,750 hours of red teaming. And that was before someone passed all 8 levels. And after that, there's kind of like the question of, did they pass all 8 levels with a universal jailbreak? And so that's actually harder than just passing all 8 levels with just like any random jailbreak for each question individually, right? And so for that took an additional 50,000 chats and additional 600-ish hours of red teaming for someone to find a universal one.
So something I find kind of interesting is that, you know, in some sense, you know, we've spent a lot of time, you know, trying to make a system that's like more robust. And it's true, like the baseline has been it gets broken in hours, and we're now on days, you know, which is like definitely a lot of progress. But like, you know, how would we know this is like safe enough, or how would we know this is like high enough? What would make us think this is actually sufficiently safe in practice, and what else would we need?
I mean, I think the real gold standard we want to hit, driven by the responsible scaling policy, is to be able to make a safety case, like a really clear argument that even though the model has a certain dangerous capability, we don't actually think that the model will be able to pose with our safeguards, be able to pose the risks associated with that dangerous capability. And I think, roughly, I think based on this result and the rapid response paper that we had earlier, I think one approach that seems like quite promising for how we would go about making the safety case once the models do become capable of more serious misuse risks is basically to build a very good sort of like constitutional classifier based system, which takes thousands of hours to jailbreak. Then have some kind of so that will mitigate lots of jailbreak attempts, like a vast majority, but some will still go through. And then we need some other mechanisms to basically like detect and then respond to those additional jailbreaks. So those mechanisms would be like some kind of bug bounty program where people can report jailbreaks and be given monetary rewards for reporting jailbreaks. and B, probably some kind of like incident detection or like offline monitoring to after the fact detect that like some of the traffic like involves some jailbreaks that we didn't notice with our immediate like classifiers that are deployed like online, immediately blocking the harmful outputs. And yeah, I mean, you can imagine like various things that could work there, but yeah, for the online system, the classifiers need to be like pretty efficient and like small and have lots of different constraints. Like they also need to support like token by token streaming, since that's important for like reducing latency to immediately get a response from the first token. So that definitely like there are a lot of constraints there which make those classifiers less effective than you otherwise could get. But then you could serve the response and then after the fact use a much more expensive classifier like your largest, most capable model, maybe with a lot of test time compute and like reasoning through whether or not this response is harmful, maybe flag the most dangerous responses, maybe flag a number of those, and then even have the humans look at like have human reviewers look at the most those top few ones to see like are any of these real jailbreaks. Like you can imagine a really like heavy duty system like that to detect like additional jailbreaks. Then like if you do notice there are some additional jailbreaks here, use the rapid response approach we described, where you take those examples, proliferate them to get more automatically with LLMs to get more examples of jailbreaks, then retrain your classifiers, redeploy the classifiers. So yeah, that system like overall, basically the hope would be that this gets the fraction of time at which there's like an open universal jailbreak down to like a reasonable amount, such that like if you're trying to follow some like complex scientific process to like make some CBRN weapon or do a lot of like cybercrime, like there actually is just like only a small window of time to like use the model for the steps that you're going to take. And yeah, I think if it's like, well, only like 0.1% of the time there's an open vulnerability that you can use, like that just makes it like very difficult to use the system. So yeah, I think that would be like roughly the sketch of like the kind of like safety case that we may want to make that we think could be promising for using constitutional classifiers to get safety here.
Yeah. For me, it's just like another reminder of this. The only perfectly safe system is the rock, you know. They always is like really best practice in security of like, no system is perfect. Most systems have vulnerabilities, and there's always this like measure of, okay, like how much effort does someone need to put in? Like how hard is it for someone to like get the information that you need? I'm kind of reminded of I lived in like Cambridge and Oxford in the UK. Like people like cycle there all the time, and like bikes get stolen like all the time. Like I think most bikes, you just get an angle grinder and it's just gonna go straight through the lock. Like not a problem. Like those bike locks they're not like perfectly robust, you know. In the same way, like our system isn't perfectly robust, but sort of in practice, you know, you put one lock or you put two locks on your bike, you know, that basically reduces the risk like a huge amount. Like someone's gonna have to get an angle grinder, and maybe they need to be there for like an hour, 2 hours. Someone's gonna catch them, and yeah, it's really interesting because the research, like it always happens in this like broader like structure and like broader sensitive mitigations. So you mentioned the rapid response, like monitoring for new jailbreaks, then being able to respond to new jailbreaks, and there are other things we can do like monitoring for people trying to circumvent our systems. We have these classifiers and we can detect when people are trying to get around them. So yeah, I'm really excited to see how this work can really, I think it's a really good research contribution, but like I'm really excited to see how we sort of put it into practice with all these other complementary defensive mechanisms. So that sort of overall we can make like a really good safety case.
I agree.
Nice. So yeah, I think we spent about 4,000 hours of effort on the demo, but we did find some techniques that sort of were able to circumvent our classifiers. So yeah, what did people try and what got through?
Yeah, so I think we were seeing a lot of stuff where people would use these kind of like ciphers or encoding mechanisms to try to like get the output to look a certain way such that the output classifier can't really tell what it's saying. and therefore wouldn't flag it. And so that was a pretty common thing that we were seeing.
Could you give an example of something like that?
Yeah, some very basic example here could be like if you use base64 encoding or like Morse code or something. These might be things that the output classifier has a little bit of trouble understanding, and so therefore it's like not as suspicious about. Some other strategies here, a very frequent one is that people try to replace the harmful chemical with like some very benign thing like water or something. And the idea here is just that when the classifiers see like, very dangerous chemical, it's just like becomes very suspicious. And so if you replace it with a more harmless chemical, maybe it becomes less suspicious. And then you try to hint to the classifier or hint to the model in some way that actually you meant this like harmful chemical, but you don't say the exact wording. And just some other minor ones here is like some role-playing attacks where you have Claude try to like act a certain way, and also some prompt injection attacks. And definitely we saw a lot of cases of people just like resampling a lot of times to try to get a better output that would get past the grader system.
Oh, so using the feedback that we...
Exactly, yeah.
Yeah, I often think, because we have this like basically like an additional version of Claude that's like looking at the outputs. So the outputs now need to basically be very obviously not harmful in some way. So yeah, you get these like ciphers or, don't talk about like, siren gas or like PPE, talk about, refer to it with like bananas or some other like benign thing.
Yeah.
I guess one thing that I'm curious about is like what we would say to, the people who are concerned we're going to use these techniques to stop them being able to do what they want with Claude, and sort of why we've gone for the classifiers approach and the constitutional approach.
Yeah, I mean, I think definitely my hope is like this should improve your user experience for any tasks you're trying to do which are not actually dangerous. So yeah, I mean, I think, I would just guess getting classifiers to be really effective is just better than training the models themselves to reviews or not. And we can just more granularly like pick out the behavior that we want to block. And so hopefully this just like is just a Pareto improvement. It's like better user experience for everyone. And also like more safe in terms of like reliability at blocking the actual bad stuff.
Yeah, and another way I also think about this is that we want to really be able to like leverage the benefits of like really advanced and like AI with like advanced scientific capabilities. But actually, if you don't have adequate protections in place, it's for one, like according to our responsible scaling program, we actually just cannot deploy that system. We might come around and we have some like new version of Claude that's like absolutely amazing. Like we really want to get it out there, but we just don't actually think it's responsible. We've like done threat modeling, we're concerned about the risks, and there's a way of saying like if we don't have adequate protections in place, like we are unable to actually like reap the benefits in like a responsible way. So it's kind of like having the safeguards alongside like the advanced capabilities means like both together you can actually like responsibly and safely deploy like really like new like advanced systems that can do really crazy things. I think you sometimes see this actually like on like Twitter and different communities. There are like one group of people who are like AI is great, it's gonna like do all these good things. That's true, and it can do all these things. And like there's like the accelerationists, and they want to like go ahead, like let's get really advanced AI, let's get that now. And then there's like that community, and there's like this other community of people who are concerned about the risks, and there's kind of like truth there too. Like there are risks, and there are risks that we're concerned about and that you want to mitigate. And like something that I like about the responsible scaling program is that like it has some like nuance. Like there's like one position that someone could take, which is like accelerate as fast as you can, or just stop. And I kind of think this with the responsible scaling program, it's like, okay, what we're going to try and do is we're going to see and try to predict what risks might occur. Like watch out for those risks. And when we're seeing evidence of those risks becoming real, put the relevant mitigations in place. And if we can't mitigate it appropriately, maybe we do not deploy or choose not to deploy. And I just like that this is just like a much more like nuanced strategy, because I think in some ways we are operating under a lot of uncertainty. Like we don't know exactly what's going to happen. The risks, some types of risks are, sometimes it feels like you're reading sci-fi stories, and that doesn't mean you discard them, but it doesn't mean that they're necessarily 100% guaranteed to happen. So it's kind of like, how do you like navigate that place and sort of this uncertainty in a way that's like responsible, that's going to allow us to like capture and sort of distribute the benefits of like potentially having this like really, really like beneficial and powerful technology without like incurring unnecessary like costs on the rest of society and these sort of negative externalities. Curious if you guys have any like favorite memories from from the project.
I think it's just really funny, with our prototype system, that like we knew the false positive rate was high, but then when we actually like saw the result of the experiment of running it on the Claude.ai data, we're like, oh, that's like a lot higher than I kind of thought. And that was like pretty interesting. We didn't think it was like that high, but it was pretty high.
Yeah, I remember just this wasn't my personality. Kind of just like anxiously refreshing the demo, being like, how many people, like, oh my god, they cracked level 4. They're coming for us. Yeah, it was also really, really cool to see really a lot of the human creativity, like from the red teamers and some of the stuff that they came up with. It's like really, really, really smart. Yeah.
I mean, yeah, there's probably two that come to mind. I mean, I think one thing we started to look at this line in the RSP on successfully pass red teaming. I think this line gave Mrinank in particular a lot of stress because he was like, what does this even mean? What's the exact bar here? And then he went off and did like a 2-week project on figuring out how to operationalize this.
Yeah.
And he like went and talked with a lot of people about like what are the different threat models that we want to really guard against for the responsible scaling plan, like what would make us feel like we could make a really good kind of like safety case or argument. And then he came back with like a long doc, and in the doc he specified like we need to be the threat model is you need to answer a list of I think it was like 10 questions or so, and you need to be able to do that. You need to be able to like block someone from getting answers to these 10 questions after they've done red teaming for over 2,000 hours was the bar. And we're like, okay, we're going to aim for this bar. And like, I don't know, I'm just like really proud of the team that like we actually did hit that. Cause I don't know, we kind of like said that up front, like a year before we finished the project.
Yeah.
And now we got like hit that level. I think that's like really, pretty, I guess impressive like goal setting and then achievement of that. Like, it seems kind of rare for research projects to actually do that. I think the other one memory that stands out to me is, I guess we were doing robustness research, but then we read this scary line in the RSP and really thinking about it. But then we were like, oh, this is talking with people about like who's doing this. And we're like, oh yeah, like our kind of like applied like safeguards team, I guess, it's called the safeguards team now. But like originally this team was like part of our kind of like alignment science research team. And so we were like, oh yeah, like the safeguards team is like responsible for doing this and like they'll have it covered. And then we set up a meeting with some of the people on the team and they were like, who's going to achieve this level of robustness? And then we were like, oh man, this is really tough. I guess we have to solve this problem, which didn't seem like it was our responsibility. Then, that was sort of like that week we went through like an arc of realizing it was actually our responsibility to solve this problem.
I view it as kind of like, it's kind of turned out that as far as we could tell, like we were the best people to do this job. Like in Anthropic, like given the situation, like given the circumstances, given like everything else that was happening in TNS and safeguards, and then there was this like, okay, like if we are the best people to do this, let's just try and do our best there. And then I kind of think there was this like attitude in general from the team of just being like, okay, we don't know what the target should be, let's try and figure it out. We don't know what the approach to get there. And we were actually doing it like another approach. So we were doing adversarial training, we were fine-tuning models, and we were like, no, we don't think that's going to get us there. And kind of just like actually quite consistently just like pivoted to what we think was going to get us there.
Maybe what's not clear from the paper is like this was a huge engineering project, probably like 5 FTE years, roughly. I think that's like not obvious when you read the paper. Maybe it just looks like a really simple method, but I think, I think like the people on the team did a lot of like making LLM like pipelines for generating the data. I think, it seemed very important for like augmenting the data with different transformations, like translating the data into different ciphers and then using that to train that data to generate the classifier data. But yeah, I guess those are a couple of like tricks that were like salient to me and like insights. But yeah, I guess I'm curious if anyone else wants to chip in with like other things that are like pretty important or non-obvious things about how to get this to work well.
I think a lot of the research project was in fact like defining what the problem was in the first place. Like we had like some kind of like vague mandate from the RSP, but there was like a lot of work in like defining like what the criteria would be. There's a lot of work in defining like what does it mean to have like human red teamers, and like what would it mean for that to like be sufficient? What kind of constitution should we have? Like what threat model do we actually care about? Like where do we draw the bar on like specificity? Do we need both an input and output classifier? And that kind of like depends on like what kind of threats we're actually looking for. So I feel like a lot of, for the evaluations, for example, like how much do we care about the transformations? Like how many augmentations is too many to be like kind of like unuseful, like unspecific. So I think like a lot of difficulty was kind of like actually defining the problem and kind of narrowing down like the thing that we were trying to solve. Like trying to make the evaluations good, trying to find like what the decision boundary should even be. And I feel that we've actually like made a bunch of progress on even defining the problem. I feel like more confident about us tackling like similarly shaped problems in the future. So for example, if we have like, in the same way that the Constitution can be applied to like many different problems, I think we have like a better sense of like how we might tackle this kind of like big vague problem. Like how would we actually approach a threat modeling problem like this? How would we even start thinking about like how to make a safety case for this thing? Like what would constitute like a sufficient eval? Like what would constitute like a red team, like a human red teaming based like safety case? So I feel like I think we will be able to apply like a lot of things that are like kind of like fuzzy or like maybe not like explicitly written down in the paper to other problems, like maybe not just in misuse, but also like in misalignment or control, things like this.
I'm also really excited about this. Like directly practicing at like building safeguards that we can deploy in practice, and like getting and constructing the evidence, and like honestly assessing whether we think they're actually sufficient. There are like so many things like how do you run the meetings? Like how do you track the goals? Like really like mundane things that, at least often as researchers, it's not the obvious thing or the first thing you think about. Like when I was in my PhD reading papers, I would always just go straight to the method, that's what's interesting. But no, I think we learned so much at like basically like running and executing on like projects like this.
Yeah, I mean, one thing I was going to say here is like, I think a really critical difference of this project relative to other research I've ever been involved in is that it was basically, we had to solve this research problem on a very clear timeline with a fixed quality bar. So like we had this like 2,000 hours of robustness bar that we had set for ourselves internally. And it basically seemed like the deadline was sort of like external in the sense of like external to our team in the sense of like, well, their like model capabilities are progressing at a certain rate. Like the company is like Anthropic is like deploying new models. Like we don't want to be the long pole that causes the company to have to not deploy a model. And so, I think there were just like, we would constantly be thinking and talking with other teams, like when do we think we might have a model that achieves like a certain dangerous capability level? And like based on that, we were setting like basically like back chaining from that, doing sort of like engineering style planning, like week by week, what do we need to have done in order to like hit that timeline? But also while still having, I think with a fixed quality bar, it's different than like a paper deadline, because with a paper deadline, you can just say like, well, we're just going to throw out these results. This is what goes in the paper.
Change the problem you're trying to solve.
Yeah, change the problem you're trying to solve
before the paper's due.
Yeah, exactly. Claim less or whatever. Like, I think you can like really adjust the quality bar, but like here we couldn't. Yeah. And so that was like partly what that was initially what forced us to even take the classifiers approach, because we're not on track to hit the timeline that we were wanting to hit, with the previous approach. But also it led to like other difficulties. For example, like a number of people on the team were like facing difficulties with like how to plan, given that the timeline is uncertain, and that we kind of needed to take a conservative estimate of the timeline. And so I think there were like a bunch of decisions that I think like team members made, being like, oh, we're just gonna like write some code in like a Colab notebook in a way that's like not super reproducible, just to quickly generate some data so that we can train this next version of the classifier. When if we had like a longer timeline or a more clear estimate of the timeline, we would have done this like in a Python script that's reproducible and like had some general tooling for this. So I think that I'm not actually sure what we settled on in terms of like in hindsight what we should have done. I think just like maybe like not taking too conservative an estimate, so that we have like a longer time window for when like to give us the amount of time we need to allow for some of the tooling work to happen. But at least like picking your strategy in a way that the overall strategy could hit the timeline that you need. I don't know if like other people have thoughts on some of this.
I guess like, I mean, taking a step back, I feel like this really makes me think about just like, this is an interesting time for safety research in general. And I think a lot of like research is like, I guess research in safety kind of started out to be like a little bit blue sky. Like people are like speculating about like what models might be like in the future. And I think we're starting to see like kind of these like threats materializing, and we also need to like adapt our research into actually being like usable in production. So I feel that as like a research team, we're solving like kind of an interesting meta problem in a sense of like, how do we like adapt like our normal research techniques to actually like make things like happen in the real world. Mm-hmm. I think that's like something that like, safety research as a whole has to like grapple with, is like, we actually need to like solve these problems now. We don't necessarily have like a lot of time to just like kind of do a lot of like blue sky research. And we want to actually make things like work in practice. I think interpretability is also like running into this, where previously people are doing research on like maybe very small models with like very few layers or something like this. And a lot of their problem is like, scaling things up to like tackle like a real model is like not a very small engineering feat at all. I think it's kind of interesting and I guess scary that we have to like actually really get our shit together and make things like really work in practice.
Yeah. I think the other point I would make along that vein is that one thing that was really helpful, surprisingly helpful to me about in this project was just like talking with product people, just being like, what are the actual constraints for the system you want us to deploy? Like how much would you prioritize different things? And I think there are definitely like some key surprises there. At least to me, I was like very surprised by how important like streaming support is in terms of like being able to show each like generate word by word and show that to the user. That's like very important for lots of applications, and is like not something I would have necessarily realized beforehand. Each of these applications, if we don't hit the safety bar, then we may not be able to deploy in that new domain. And I think just like getting a stack ranked list of like what are the most important for the company to be able to deploy, and then just like prioritizing those use cases. That's in particular how we ended up at like this like token by token compatible classifier. And I think in general is like a very good principle for supporting like for future risks. I think we'll have the next generation of like risks where we need even higher levels of robustness. I think this is a good strategy for getting safety there, or for misalignment risks related to AIs themselves doing bad things. I think we'd take a similar approach as well.
Great. It's been really lovely to be here, and chat with you guys and sort of kind of celebrate the sort of progress and also like look ahead to all the challenges that we're going to face and things like this. So yeah, thanks so much, and thanks for tuning in.